Hey guys, my name is Carberra and welcome to the series where I teach you how to manipulate images in Python. In the last video we covered how to add filters to images, and in this one we're going along the same sort of vein in adding color filters. Now the actual method of doing so is a lot different, and in this video it's actually a lot harder. This is going to be quite the difficulty spike from the last videos, so yeah, strap yourselves in. Of course, if you find the video helpful at any point, then hit the like button to let me know, and consider subscribing and hitting the notification bell so you don't miss out on future installments of the series. But yeah, with all that out of the way, let's get into it. So, as I said in the introduction, this is going to be a long and complicated one. However, we are going to start with something really quite simple, which is converting an image into grayscale. This can literally be done with a single line of code, I'm not even kidding. And then after that, we are going to do some pride filters and transpride filters, because here at Carberra we are very inclusive of other people, and also they just happen to be really good examples of what I want to show. So we do actually have a new import. We have import random, and then from pill import image, and then image draw. And then we can do our simple if name double equals main, and then with image.open slash images slash autumn fox is the one I'm going to use. However, I may actually do this on multiple images. .jpg, sorry, as im. And the first thing we're going to do is convert the color space. So im.convert RGBA. Now we don't need this one for the grayscale, but we do need it for the others that we're going to do. Essentially, when an image is loaded in, it's loaded in RGB, which is so you have your red value, your green value, and your blue value. In RGBA, you also have an alpha value. So these values are the same, but you also have an alpha value. And this is the transparency. So because our filters are going to be translucent, so we actually need to be able to see the filter, but we don't want it to take over the whole image, we have an alpha value to allow us to do that. But for now, as I said, we're not going to use it with our grayscale, but I thought I'd just explain that now near the start. So if we make a function here, we don't really need to make a function, but I'm going to make it just so everything's a little bit cleaner. And then we could do return im.convert L. So this actually converts the color space again. So it's not the most efficient with RGBA here, but whatever. And this converts it to luminance. So luminance is a single value between 0 and 255, and it essentially controls the white value of an image. So 0 is jet black, 255 is pure white, and it will appear grayscale. So if you come down here and say grayscale im equals grayscale im. Oopsie daisies. And then do grayscale im dot save, and then dot slash saved images slash grayscale fox. I can't be asked to put the full name. And then we're going to save it as a PNG. Again, we don't have to. Oh, save it as a JPG. Why not? I'll say you don't have to save it as a PNG if it's a luminance color space, but you can save it as a PNG if you want. And then if we run that, oh, we need to do that and then that. There we go. We should have this grayscale fox, and as you can see, our fox is now in grayscale. It looks very LA Noir, doesn't it? In here, it actually looks very imperial, just kind of sitting there in grayscale. But you know, wasn't expecting the fox Q so soon, but apparently it's here, so everyone run and hide. So, with that out of the way, we're now going to do our other filters. I'm actually going to construct the functions first, and then I'm going to make the function that actually creates the gradient last, because I feel as though it'll make a little bit more sense if I do it in that order. So we're going to have our pride filter, and we're going to have im, and then direction equals diagonal, because we are going to have direction support. So what I mean by direction is, so if you have one in a diagonal, it will go from the top left corner to the bottom right, and the gradient will kind of go diagonally across the page. If you have a horizontal one, it will go horizontally across the image. And if you have a vertical one, or vertical direction, I should really say, it'll go from the top to the bottom. I just thought I would add that in because I knew that I would get questions if I didn't, because I got questions in the stream. So I just added it in, even though it adds a bit of extra complexity. So we're going to have our grad, which is kind of a new, we're creating a new image, but this is really a new layer for what we want to do. So RGBA, and then im.size, so we're making it the same size in RGBA. And then we're setting the base color equals 0, 0, 0, 0. I'm not 100% sure if you even have to do that, but I'm doing it anyway. Then we're going to have the colors. So this is a tuple of tuples. It can be a list of tuples, of course. But these are the different colors of the pride flag. And essentially what these colors are different steps. So you'll start on the red, and then it'll end here on the orange, and then it will start on the orange and end here on the yellow. Essentially because it's not really possible to create a rainbow gradient if you don't have just a list of colors here, which is why I'm doing it like that. So we could do our grad equals draw gradient, which is the function that we're actually going to be creating. Then we're going to pass grad into it, have our colors, or pass all our colors into it, and set the direction equals direction. We're also going to grad dot put alpha as 127. So the alpha is a value between 0 and 255 because of binary. So 127 is at least as close as you'll get to 50% transparency as possible. It might be exactly 50%, but I'm not actually 100% sure about that. Either way, it's very marginally off. But this allows us to actually see the gradient and see the image underneath it. And then we're going to return image.alpha composite imgrad. The order in which you pass these files through, or these images through, is important. So don't put grad first. I believe you can do im.alpha composite grad, but I don't know how well that works. So I'm just doing it like this. You can try it if you want. And then the trans pride one that we're going to do is actually extremely similar. It's just a different set of colors and a different function name, of course. So you have our trans pride here, and then we have, just grab these from my notes. I am pretty much copying directly from my notes on this one, because there is a lot, and there's no way in hell I'm ever going to be able to remember all this. But yeah, these are the trans colors. So we start on, I think, the blue, and then we go to the pink, then the white, then the pink, then the blue. It might be pink then blue, but I don't think it is. I guess we'll see when we actually apply the filter to the image. So with these functions created, we can actually go up to the very top and start our draw gradient function. This is where I'm going to be spending most of the rest of the video. So yeah, this is the bit that's kind of complicated. So we have an internal function here. I think it's an enclosed function or something like that, called interpolate. I know the technique is called closure, but I'm not sure what you'd actually call the function in that. I believe enclosed is what you do, but I don't know. So I'm going to write this function and explain it all in one go, because I feel it would be easy to do that way. So we have diffs equals a list of t minus f divided by lines for ft in zip start end, for I in range lines yield round value plus diff multiplied by I for value diff in zip start diffs. So while you're getting that down, I'm going to explain what the hell this is actually doing. So it's taking the start and the end, so say the start and the end down here, and this diffs is essentially a 3-element list. You can make it a generator if you want, I think. I actually don't know. But essentially it's a 3-element list, and it is saying the difference in red, the difference in green, and the difference in blue that we need every line. So this then iterates through the lines, and this yields, which turns this into a generator function rather than just a standard function, returns a 3-element list of its own, which is the color that we're going to draw. So essentially it takes the start value, and then it adds essentially the difference to it multiplied by the line that we're currently on. So essentially it will just like multiply all the differences together and give us a color we can use. It looks really rough, but the logic is fairly simple, thankfully. So outside of that function now, we can do def image draw.draw. And when I say outside of the function, I mean outside of the interpolate. This is still inside of draw gradient. So make sure your indentation is correct. And then we're going to do if direction equals vertical. Actually, we're going to do horizontal first. I think that makes a bit more sense. And we're going to do lines equals image.width divided by len colors -1, and that actually needs to be in brackets of its own. The reason why we're doing this, and the reason why I'm going to be doing the same for vertical as well, is because depending on the direction that we are actually going, the number of lines that we need to draw is different. So this would be image height, len colors -1. This is so this is getting the number of lines for each individual color. So this is getting a number of lines, say, between the red and the orange, essentially. And I'm going to put else in here. You can put elif direction equals diagonal, but I'm essentially just kind of bulletproofing this a bit harder. I don't really want to introduce like proper error handling into this because it's complicated enough, but you can mess around with that should you wish to. And then for the diagonal, we're going to do image width multiplied by 2 divided by len colors. And this lines is actually within the scope of this function because lines is defined here. This function here actually has access to that variable, so you don't need to like pass it in or redefine it or anything. It would be perfectly fine there as is. And then we're going to set our line number to equal 0, which is our first line. And then we're going to start iterating through stuff. So for line, in range len colors -1. So for every color step, we're going to take for color in interpolate. So we're going to get all the colors we actually need for this particular section of the gradient. I told you it was complicated. And then we actually need to do different things for the direction as well. So if direction equals horizontal, then we do draw dot line, and then have that, and then we have a list. And then we have inside here, we have 2 tuples. So we have line number 0, and then line number image height. So essentially this is drawing a line from the top of the screen to the bottom of the screen, or the bottom of the image, I should really say, at the x coordinate of the line number. So as this iterates, it will like slowly tick along the x-axis, drawing a new line. And then we need to also do tuple color. And then actually, do we need to do tuple color? I'm not actually sure. I don't know if we need to do tuple color. I'm going to omit the tuple for now because they are already tuples. So I'm kind of hoping that we don't. Actually, it'd be a list. I think it'd be fine to do it like that. We'll see. And then we'll set width equals 1 because we just need it as 1 pixel. And then we do elif direction equals vertical. It's very much the same logic here. Draw dot line and then a list, and then you have your 2 tuples, and you essentially swap them around. So you put a line number on the y-axis now, and then the other variables on the x. So this means it's slowly ticking down the screen this time. And then we have our same variables here. Or same parameters, I should say. Else, again, you could do proper error handling here if you want. Draw line. And then this one is a little bit different, but it's a little bit simpler. So line number 0. And then 0 line number. So if you remember when we did the cross, it's exactly the same idea, really. And then we can pass in color, and then we can do width equals 1. And then we need to, still inside this for loop, we need to add 1 to the line number. And then after everything, we can return the new image. So this is our new function. I'm just going to check to make sure I haven't actually forgotten anything. It doesn't look as though I have. But this is, so this is the function to draw gradients. The reason I did a function like this rather than putting them in here is so you could just draw the gradient here, and you could just have a set of colors, and this allows you to draw any color gradient you want. I believe this will error if you only pass in 1 color. I actually don't know. Actually, it may just not do anything at all because of the way this bit functions. But you can pass in as many colors as you want. So you can pass in 3, you can pass in 50. I don't know how it looks with 50. I imagine it doesn't look amazing. But you could, should you wish to. But I'm gonna separate that real quick. And then we're gonna have pride im equals pride im. And then we'll keep the direction diagonal for now. But that is literally all you need to do. Once you've written this, you could just attach this to anything, like that. And then pride im.save, saved images / pride fox.png, and this needs to be a PNG. You can't save this as a JPG because it's still using the RGBA color space. There may be a way to flatten the image in such a way that the alpha value becomes irrelevant and then you can save it as a JPG, but the way we're doing it, it won't work like that. So yeah, we're just going to save it as a PNG because I prefer the PNG file format anyway, I'm going to be honest with you. So .save, /saved images / and then transfox.png, and then hope that we don't get any errors. We do. That's amazing. Oh, it's because... Oh no, I've got that one. This is... yeah, all the times I've done image, I need to do im. It's image in my plan, so I just got confused. Oops, it is. It's not what I wanted to do. This is all im, not image. And then I think there's stuff down here as well. Yeah, there's all this. There's these two. It should just be im. Color referenced before assignment. I didn't make this colors. And then color must be int or tuple. Where is that? Oh, yeah, it is a... Okay, it was necessary. All right. I should have followed... I should have trusted it. I should have trusted the plan. It was indeed necessary. That's strange it doesn't accept a list. It's not too difficult to implement. Okay, there we go. We're getting something there now. And the Pride Fox... Oh, that makes sense. Okay, so we did get a few errors, but we didn't get too many, so I'm not too upset about that. And then, the grand unveiling, we have our Pride Fox. There we go. Well, that's actually probably a bit too much on it. But as you can see, we start from the red, and then we slowly fade into the orange, and then we slowly fade into the yellow, and then we quite sharply fade. I'm not sure if that's just me, though. Into the green, and then we fade into the purple one, and the pink is down here. Then we have the trans one, so it does start with the blue. And then we kind of go into the pink. This one's a lot less obvious. And then we go into the white, and then we have the pink again, and then we end on the blue. It doesn't appear to be going all the way, which is interesting. Does it go all the way with the Pride one? It does. The trans one doesn't go all the way. That's very strange. I'm going to see if I can try and diagnose that real quick. See if there's any reason why the Pride one is working perfectly and the trans one isn't. Hi there, editing me here. It's actually been a while since I featured on the channel. Haven't had to come in too often, but I just wanted to jump in here and say that I think I've kind of theorized the problem in editing. I didn't actually manage to fix it in recording, but I think there's probably some inaccuracy while calculating the number of lines, because the code that I adapted was just a single gradient, so it just went from one color to the next. It didn't have steps. So I think there's some sort of weird mathematical error in calculating the number of lines that are needed. I'm not 100% sure, but feel free to experiment with it and let me know if you do solve it. I might as well show you the different directions while we're here. So you have a horizontal, and then we'll do this one as vertical to save it just a little bit of time, because this video is starting to get probably rather long. I don't actually have the timer up at the moment, which is probably not great. But this one was horizontal. So as you could see, the image, we start on the left with the red, and then we go across all the way to the right. And transfox, it's I think this one is actually probably more accurate to the trans flag, because it is this orientation. But you start with the blue, and you go to the pink, and then you have the white and the pink and the blue. It's actually a really cool little feature. It almost looks kind of glass. It's weird glassy effect. That's actually really cool. As always, if you have any questions, don't be scared to leave a comment or ask in the Discord server, which you can find in the description below. But yeah, with that, I'd like to thank my super patron Darky and all of my other patrons for being as awesome as they are. And I'll see you next time, where we actually wrap up the main part of the series, at the very least, with some masks.